In this video, we're going to walk through a few examples of ionic compounds that have polyatomic ions. Polyatomic ions are going to be anything that has more than one nonmetal atom. And in these ionic compounds, those nonmetal atoms are going to be covalently bonded together. They're going to be sharing electrons, and those covalent bonds won't break just because we dissolve them in water, where some ionic compounds will break when they dissolve in water. So we're going to rely a lot on our polyatomic ion chart, so we don't have to memorize the names and charges associated with these. There is one in your kind of like easy, handy fact given information for exams that you can reference. So let's go through two examples. Let's start with calcium carbonate or calcium and carbonate. So we're going to try to decide what compound will form when we combine these two. So calcium is going to be my metal. It is in the second group, and that means it's going to have a +2 charge when it forms an ion, and it'll act as a cation. Carbonate is not just an element. It's actually a polyatomic ion. And some of the clues of that are the ATE ending on this. It's not carbon, it's not ide. We always use IDE for the anions that are monoatomic. Like if carbon was an anion, it would be carbide rather than carbonate. So once I recognize that I have a polyatomic ion I'm dealing with, I'll look at that chart and look up carbonate by name. And I'll find it's CO3. It has a -2 charge overall. And so this is going to be one carbon atom that's bonded to 3 different oxygen atoms. And the overall molecule has a -2 charge associated with it. And when we talk about covalent bonding in the next chapter, we'll go through what that looks like in detail. For now, we're just going to think of it as a big ball of -2 charge. And it's going to be interacting with this calcium ball of +2 charge. And they're going to be attracted to each other. So I'm going to write out my calcium as calcium +2 and my carbonate as CO3 -2. And now I'm going to figure out what they're going to form in, or sorry, what ratio they're going to combine in so they form a neutral compound. So looking at these, I've got +2 and -2. These are already equal and opposite charges in terms of the positive and negative sign. So they're going to combine in a 1-to-1 ratio, and I'll be able to write that as calcium followed by the carbonate, like this. It's important to note when we're looking at this that the carbonate is the anion right here. So if you were given the chemical formula instead, I would see those 2 nonmetals right next to each other, and it would tell me that I had, would be my red flag that I had a polyatomic ion. And if I was given just this chemical formula, I could actually determine the charge on that carbonate ion without looking at my handy dandy chart, because this calcium right here is one of our representative elements. Because it's a group 2 metal, I know it's going to be a +2 charge no matter what. And since I have only one of these carbonate ions, it means that it has to have an opposite but equal charge, or a -2 charge. All right, now let's combine polyatomic ions and transition metals, kind of 2 of the harder pieces of ionic compounds. We have an example here, copper 1 sulfate, and let's try to determine what the chemical formula is from that. So copper is a transition metal, so it can have lots of different charges. It can be +1 and +2 most commonly. And so this 1 in Roman numerals right here tells me it is a +1 charge on the copper. So I'm going to write that out now, my copper +1. Now the sulfate, again, I have an ATE ending, not IDE. And so I know immediately just from that name that I can't be dealing with a monoatomic anion, because it's just not named the way we were taught to name them. So I'll run to my polyatomic chart and I'll look it up, and I'll find out that sulfate corresponds to SO4, and it has a 2 charge overall. So with my SO4 -2, I am going to try to balance out that charge with these copper +1 ions and determine what ratio I need. So I can use my crisscross rule, and I'm like, oh, okay, I'll put this here and here. That means I'm going to need 1 of my sulfate and 2 of my copper. I can also just compare these two charges and say that if I have a +1 charge for my copper and a -2 charge for my sulfate, and I need the opposite but equal charge, I need to multiply that smaller numeric value by some other number. And that X value will be 2. So I'll have copper, 2, sulfate. And again, it's that SO4 altogether that is my anion, my polyatomic anion.